In my previous video, I introduced Rolle's theorem, and I've explained it from a visual perspective. In this video, I want to apply Rolle's theorem, if possible, to a function, or maybe we'll do a few functions, and determine this value of c that Rolle's theorem claims exists if certain criteria are met. So remember, Rolle's theorem is an existential theorem, and Rolle's theorem says if certain criteria are met, then there exists this certain value of c. So let's talk about the criteria for Rolle's theorem. Well, we need the function itself, f of x, is continuous on the closed interval a to b, differentiable on the open interval a to b, so continuous from a to b and differentiable between a and b. And we also need f of a to be equal to f of b. And if these three criteria are met, then Rolle's theorem says there is some number c, some x value c, between a and b. It's not going to be equal to either a or b, the endpoints. It's got to be between a and b, such that f prime of c is equal to 0, or the graph has a horizontal tangent line. All right, so let's look at an example. Let's say f of x is equal to 3 minus the absolute value of x minus 3. And let's look at the interval, let's say 0 to 6. So the absolute value function is continuous everywhere. So we have continuous. F of 0 is 3 minus 3, which is 0, and f of 6 is 3 minus 3, which is 0. So f of a is equal to f of b, but it looks like there's a problem with the derivative. So remember, a function does not have a well-defined tangent line. A derivative doesn't exist if the graph has a sharp corner or sharp turn. The absolute value function does. In this case, when x is equal to 3, there's a sharp corner on the graph. So f prime of 3 is undefined. And since 2 but not all 3 of the criteria are met, we would say Rolle's theorem does not apply. All right, so let's look at another one. Let's say g of x. Say g of x is equal to x to the 2/3 power minus 1 on the interval -8 to 8. Well, this power function, x to the 2/3, is continuous everywhere. There's no issues with the domain there. So we have that f of x is continuous. And if we plug in 8 or -8, we're going to get the same number because we're squaring it. This is x squared and then cube root. And so since we're plugging in a positive or negative of the same number, -8 squared is 64 and +8 squared is 64. So we're going to get the same number in both cases. So f of a is equal to f of b. Well, what's the derivative? Say g prime of x, let's use the power rule, 2/3 pops out front, so we'll have 2/3 x to the -1/3 power. The derivative of the 1 is equal to 0, so that's it for the derivative. Or we could rewrite this 2 over 3x to the 1/3 power. And again, we have a problem with the derivative. The derivative g prime of x is undefined when x is equal to 0. If you plug in a 0 to the derivative, you get undefined. So f prime of 0 is undefined. Well, let's do one more, and I'll make sure this one works out. Say h of x is equal to x over 2 minus the sine of pi x over 6. And let's look at the interval -1 to 0. Well, if we plug in -1, h of -1 is equal to, that'll be -½ minus the sine of -pi over 6, and the sine of -pi/6 is -½ So we have -½ minus a -½, or -½ plus ½, which is 0. And h of +1. So if we plug in +1, we'll get 1/2 minus the sine of pi over 6, which is 1/2. So we get 0 again. Okay, so it's a sine function, so it's continuous everywhere. So we have that the function is continuous. We have that h of -1 equals h of 0. And let's look at the derivative. So we're going to take the derivative of the h function. So h prime of x is equal to, well, the derivative of x over 2 is 1/2. And the derivative of the sine function is the cosine function. And we'll have to apply the chain rule. So that should be pi over 6 times the cosine of pi x over 6. Okay, so the derivative is defined everywhere as well. There's no problems with the derivative. So we have that the function is continuous. We have that the function is differentiable. And we have that the y value for the -1 and the y value for the 0 are both equal to each other. So Rolle's theorem does apply. Rolle's theorem applies. Okay, so if Rolle's theorem applies, it means there's the existence of some value c. Well, there may be more than one, but there's at least one value of c where the derivative is equal to 0. So let's set the derivative equal to 0. That's how we're going to solve for c. So we'll say, okay, 1/2 minus pi over 6 cosine of pi x over 6 is equal to 0. Well, we could add the pi over 6 cosine of pi x over 6 to the other side. So we're going to be solving pi over 6 cosine of pi x over 6 is equal to 1/2. Well, we can multiply both sides by, not pi, 6 over pi. That'll cancel off those. And so now we're at cosine of pi x over 6 is equal to 3 over pi. Okay, so we're solving for x. So we have to get rid of the cosine. So we could take the arc cosine or the cosine inverse of both sides to eliminate the cosine. So we have pi x over 6 is equal to the arc cosine or the inverse cosine of 3 over pi. Okay, and that looks good. And so now solving for x, last thing, we can multiply both sides by again, 6 over pi on the left, 6 over pi on the right. And so x is equal to we need this arc cosine. We need this value to be in -1 to 0. So we need we need a negative sign there. Don't forget that. And so x is equal to negative 6 over pi times the arc cosine of 3 over pi. And that is our value of c. So we could say, so c is equal to negative 6 over pi times the arc cosine of 3 over pi, or we could pop this into the calculator. This is not something you would evaluate on your own. So we can pop this into the calculator. And so c is approximately negative 0.5756 radians. We don't need the units here. So you could, depending if this is a question on the homework or a quiz, the directions will clearly state, give the exact answer, which would be this, or give a rounded decimal, which would be this. So normally we would plug this into the calculator. Okay, so that does it for these 3 examples. In any of these problems where you're applying Rolle's theorem, it's 2 parts. Part 1 is, does the theorem apply? Which means you have to test, is your function continuous on the closed interval? Is your function differentiable on the open interval? And does f of a equal f of b? If each of these 3 criteria are met, then in that case, then you would solve f prime of x is equal to 0. Set the derivative equal to 0 and solve, and your solution or solutions will be those value or values of c. Okay, that's all for this one. Hope it was helpful.